Welcome to the next level of decentralized AI. In our previous tutorials, we built AI tools that could tell time and manage a counter. Today, we're doing something truly powerful. We're building an MCP server on the internet computer that allows AI agents to securely manage user funds. Imagine an AI assistant that can't just answer questions, but can transfer tokens, check balances, and manage on-chain assets on your behalf, all secured by your standard web login. By the end of this video, you will understand how to, first, implement MCP tools for common financial operations like transferring tokens and checking balances. Second, leverage OAuth to securely identify users. And most importantly, use a user's digital identity to create and control their own unique, secure sub-account on the blockchain. This is where AI meets decentralized finance. Let's get started. So how can a single application, or canister, manage funds for thousands of different users without mixing them up? The answer lies in a powerful feature of the Internet Computer's ICRC1 token standard: subaccounts. Think of our main canister as a bank branch. It has one primary address or principal, but within that branch, it can manage countless individual safety deposit boxes or subaccounts. The magic is how we assign a box to each user. Our MCP SDK combined with OAuth gives us the user's unique identity token. We'll take the subject field from that token, unique identifier for the user, and use it to deterministically generate a unique subaccount for them. Just like any MCP server, we need to implement the handler trait. This is where we tell the AI agent what our server can do. In our list tools method, we define the capabilities of our financial agent. We have tools like get supported tokens to see which tokens like ICP or CKBTC are available. Get account address for users to get their personal deposit address. Get balance to check their balance for a specific token. And transfer, the key action to send tokens to another account. The descriptions are crucial. They act as instructions for the AI, telling it exactly how and when to use each tool. At runtime, our call tool implementation handles three tools: get account address, get balance, and transfer. Briefly, each tool follows the same secure pattern. 1. Extract the authenticated user's subject from the SDK-provided context object. 2. Deterministically map that subject to a subaccount under the server's principal. 3. Use the ICRC1 ledger client to interact with that subaccount, like balance of or transfer, and build transfer arg with from subaccount set to the derived subaccount. The full Rust code is in the description. And how does our server get that all-important user identity? Exactly as we saw in our previous OAuth tutorial. Show the HTTP request update function. The HTTP request update function uses the SDK's built-in handle with OAuth method. This function handles the entire complex flow of validating the JWT token from the user. Once validated, the SDK securely extracts the subject and other claims and packages them into the context object and passes it to our call tool method. Our application logic doesn't need to parse tokens or worry about cryptography. It just receives the verified user identity and acts on it. Here's the short demo of interacting with MCP server with the step login and call the tools. First, let's start the MCP server, then the MCP client will ask to log in. Then grant the permission for MCP server to confirm your identity. After that, it will automatically query all the tools. As you can see, we have 5 tools here. Then let's try to get account address and get supported tokens. Now let's try check the balance and transfer some token. Let's recap what we've accomplished. We have built a fully functional, decentralized AI agent capable of managing user funds on the internet computer. We learned how to define a set of financial tools for an AI agent using the MCP handler trait. Use the handle with OAuth method to seamlessly authenticate users. And, most powerfully, we transformed a user's digital identity from an OAuth token directly into a secure on-chain ICRC1 sub-account, enabling personalized and secure financial operations. You now have the foundation to build sophisticated decentralized applications where AI can safely and effectively interact with the world of on-chain assets. Thanks for watching, and happy building!